Continuing our review for our Chapter 2 test. We are looking at sections 2.5 through 2.8 today. The first one says our learning target is to be able to write equations, linear equations that model real-world data and make predictions from those. We have been using the graphing calculator to do all of this for us. Okay, so on the test as well, you are able to use the graphing calculator. You will not be able to have any kind of notes in terms of the keys that you need to hit. All right, so we're just going to go through very quickly how to do this. It says the following table shows ice cream sales based on certain temperatures. Did you guys have a chance to get this data entered? Yes? Okay. So we put the temperatures in list 1 and ice cream sales in list 2. They're asking us to find a line of best fit. Another term for that is linear regression. Does it say anywhere in this question that we have to actually graph it? No. Could we? Certainly. But if you're struggling with your test in terms of time management, you don't have to waste your time graphing it. It just says find the line of best fit and use that line to make some predictions. Okay? So we're going to go through those steps. We won't go through the whole graphing part of it. So we have our data entered. What keystrokes do we use to get to our linear regression? Stat, okay, our stat key. Over to calculate. And number 4 is linear regression. Okay, we've put our lists, our x's in list 1, our y's in list 2. I'm going to go ahead and store the equation because once we get this big long decimal equation, it's asking us to make predictions using it. Okay, how do we store it in that y equals screen? Go to variables, so the vars key, over to y variables, function, and we have options of where we dump it. I always just put it in y1. Okay, now I can go down to calculate and hit enter. So we're going to write down this equation. Y equals, let's go out to 3 decimals. How would I write it? Y equals, what's my A, right? At the top it says y equals ax plus b. They're giving you the setup and then they're telling you what to dump in. So A would be 4.193 times x plus our b value is negative 163.410. All right. Part B says predict the ice cream sales when the temperature is 95 degrees. What variable was our temperature? Was that the x's or the y's? That was the x's. We set it up, right? The temperature was in list 1. So they're basically saying, let's make a prediction when x is 95. So by hand, could we dump 95 in there? We could. Could we use our calculator? Yes. Since it has stored this equation in the y equals screen, it has created a table for me. Okay? It's going to take me a while to scroll down to 95 in my table. So a shortcut, when you do have to go to a value that's way down in the table, is to go to table set. It's right above your window key, so second window. We can just say, let the table start at 95. That's the number I'm looking for. Okay? I'm going to start at 95. Now when I go to the table, which is second graph, it's the first thing on my list. So the sales would be $234.96. Questions about that process? All right. We'll go back here, go back to table set it to start at 1 again. for our next question. All right. What is the correlation coefficient? Let's go back here. We did stat 4. I've already stored it. All right. Our correlation coefficient was 0.838. Is that a good correlation? What does it represent? It represents a positive sloping line, right? Our R value is positive. What would our R value be if there was a perfect fit? In other words, if every single point landed on this line? It'd be a 1. It's not a 1. It's 0.8. So it's fairly strong. I wouldn't say it's wonderful, but we can say fairly strong positive correlation. When you get down to things like a 0.5 or lower, it's a pretty weak one. I wouldn't use it to make predictions about anything. Okay. All right. Section 6. We're looking at analyzing our different transformations. For these first ones, it's not asking you to graph anything. It's just saying, what would the equation look like? We want to write an equation that translates our parent function. In this case, we're starting with a square root graph. And we want to move it left 4 units and up 1. Okay? Square root graph. If we wanted to move left 4, what would we have to see in our equation? Where are we going to put the plus 4? So it has to go inside the function. The function in this case is a square root. Okay? It could be absolute value, it could be squaring, whatever the function is. This particular one is a square root. Then we want to move it up 1. How do we do that? Plus 1 where? Outside. Okay? All right, third question here. Describe the transformations from the parent function y equals x to the 4th to the new function y equals -2 quantity x plus 1 to the 4th plus 7. Let's break it down. We always want to list them in order from left to right. The -2 that you first see does 2 different things. What are they? Okay, so it actually can do 3 things. It can stretch it or compress it vertically. And if it's negative, what does it do? It reflects it over x-axis. So when I said the -2 does 2 different things, it's because the negative is doing one thing and the 2 is doing something else. Okay? So our negative does what? Reflect over x-axis. Okay? That's the negative part of my equation. What is the 2 going to do? Okay? Vertical stretch by a factor of 2. What is the 1, the plus 1 that we see in our equation? Left 1. And then what does the plus 7 on the outside do? Up 7. All right. So this is the first step, second, third, fourth. Okay? That's the order that I would expect to see them in. Question 4 says find the function g of x that represents the function f of x equaling -3x plus 5 reflected over the y-axis and h of x that shows a reflection over the x-axis. All right, so let's take it in 2 parts. If we want to reflect over the y-axis, which variable changes when we reflect over y? The x's. Okay? Your x's change. So all you have to do is change your x. Wherever there was an x, make it a negative x. Okay? So in this case, we're looking for g of x. We're going to take our f of x function and basically change our x's to negative x's. Okay? Which means we end up with negative 3 times negative x plus 5, which gets us 3x plus 5. So the only thing that changed in my equation was the x part of it. Okay? If we want to reflect over the x-axis, what changes? Y changes. But y is the whole thing, right? Y equals negative 3x plus 5. We have to change the whole thing. So h of x is going to change everything. It's going to take the opposite of my original function. So I want to make everything opposite. That means the negative 3x becomes positive. The positive 5 becomes negative. So reflecting over y just changes the x piece. Reflecting over x changes the y part, which is all of it. Okay? Your friend wrote the transformations shown below to describe how to change the graph f of x equals x squared into g of x equals 2 times x plus 1 quantity squared minus 3. Explain the error and give the correct transformations. So let's just start with the correct transformations. What's the first thing it should happen? All right, that's going to do a vertical stretch by a factor of 2. What is the 1 going to do? Okay, so left 1, and then what does the negative 3 do? Down 3. That's what should have happened. They said they vertically shifted 1 unit up. Okay, so they're getting the left, right, up, down mixed up. They said they shifted it horizontally 2 units to the right. They're getting a vertical stretch confused with a horizontal shift. Shifting vertically 3 units down, they had that part right. Okay. All right. Some graphing. If we want to graph y equals negative 3x, what form of equation is that? It's slope-intercept form. What's the y-intercept? 0. So we're going to start at 0, and we're going to do a slope of negative 3. So down 3, right 1. And draw a line. Is there any shading in this? No. Right? No shading. Only shading when there's an inequality symbol instead of an equal sign. Okay? Y equals 2. What kind of line? Horizontal. Y equals 2. All right. Looking at graphing absolute value functions and inequalities. Where does my vertex shift to? Remember, absolute value graphs should look like a V, correct? Normally, we start with the vertex at the origin, but where are we shifting it to? Right 2 and down 3. Okay, so my vertex is going to be there. And then what kind of stretch did we do? Stretch of 2, which means it's getting skinnier. And remember that that number in front, even though it's a vertical stretch, it's the same going as the slope on the right side. Okay, so we're going to do a slope of 2. So up 2 over 1. We're going to go up 2, back 1. And draw it in. All right, question 9. What form of equation is this in? This is standard. When it's in standard form, the easiest way to graph is to find the intercepts. If we put a 0 in for y, we've got 2x having to equal 12. X would be 6. If we put a 0 in for x, we've got negative 3y equaling 12, negative 4. Now, there is no equal sign in this, correct? We pretend there is when we find the intercepts, but when we go to graph it, what kind of line are we going to have? We're going to have a dotted line. So through those 2 points, we're going to draw a dotted line. Make sure you have arrows on the ends of all this. And then this one does involve shading. When it's in standard form, the easiest way to check which side to shade is to test a point. I'm going to test the origin. If I put zeros in for x and y, do I get a true statement? Is 0 bigger than 12? No. That means the origin doesn't work. It means all the points on that side aren't going to work. So we would shade everything on the other side. All right, question 10. We are looking at an absolute value inequality. What kind of transformations have we done? So it is reflected, which means our v is going to be upside down. We moved it left 2 and down 4. Right? Left 2, down 4. That's my vertex. My slope on the right side is going to be a negative 1. So I'm going to go down 1 over 1. And I'm going to go down and back. My board is really off today. Solid or dotted for this? Solid. And then because it's an inequality, we have to do some shading. Are we shading above that v or below the v? We want y to be less than, so below it, which in this case would be all the stuff underneath. All right. Before we turn the page, I noticed we forgot one part of question 8. They asked us for an equation for the axis of symmetry. Your axis of symmetry goes right through your vertex. What would the equation for that line be? X equals 2, and our vertex ends up being at what coordinates? All right, wherever we shifted it, yes? Right 2, down 3. All right. The last part, I'm going to give you pictures, and you're going to give me the equations or inequalities. Since there's shading involved, these are going to be inequalities. Okay? Let's start with the first one. It is a line. In order to write an equation for a line, we want slope and intercept. So where does it cross the y-axis? So my y-intercept, or the b value in y equals mx plus b, is 1. And the slope, or the m value, is what? Looks like a negative 2. So our equation would be y equals negative 2x plus 1. But it's not equal, is it? It's a dotted line, so we're not going to equal it. We're going to get close. We are shading underneath the line. So what kind of inequality? Less than. All right. Our last one. It's a V shape, which means it's what kind of equation? Absolute value. So let's start out with an absolute value equation. Yes? I'm not going to put the little equal sign in because it's dotted. We are shading under the V. So we want a less than symbol again. Okay? Now we have to figure out what's the slope of the V on the right-hand side. What is the slope? Positive 1. Rise 1, run 1. Okay, so the slope on the right is 1. You can write it in, you don't have to. And then did we shift it left, right? How far? 4 to the right. So what are we going to have in our absolute value bars? A -4. Did we shift it up or down at all? All right. So homework tonight will be your blue packet.